don't see the point, see the point. No, no, no more fights and no more debate. I'm out of ways to love you. No more shortcuts that we can take. Only way out is through. I promised you long ago to be your girlfriend, your girlfriend. But somewhere down the road we hit a dead end, a dead end. Though I tried and tried, it only made me cry, and now there's nowhere to go from here. We hit a dead end, a dead end. I promised you long ago to be your girlfriend, but somewhere down the road we hit a dead end, a dead end. Though I tried and tried, it only made me cry, and now there's nowhere to go from here. We hit a dead end, a dead end. You're never here when my tears dry. You're never around to see me thrive. When it's my birthday or my day off, you got other plans and can't show up. But when life deals me a hand, all of a sudden you're the first to come. Always there to help and listen. You're just a friend when I come undone. I have to fall apart to get to see you again. You only have a heart when mine is bleeding, some kind of friend. If I would win the lottery, you wouldn't be happy for me. But if I blew it all in one day, you'd be there to hug my pain away. 'Cause in tricky situations, you are the best friend that I've ever had. But it's such a funny feeling when you get enjoyment of seeing me sad. I have to fall apart to get to see you again. You only have a heart when mine is bleeding, some kind of friend. You're never here when my tears dry. You're never.
All right. Welcome everybody to this afternoon session. I hope you had a good lunch and are able to stay awake for our new peering forum session. My name is Yolandi and I will take you through this afternoon session. And we are kicking things off with Nina giving us an update on route views. So please welcome to the stage Nina.
Hello. Thank you for letting me speak here. I'm going to talk for a while, 20 minutes I see, about the route use project. Some of you will know it as a route use. Yolanda and I just decided that at next APRICOT we will have a panel debating whether it's called routes or routes. It's going to be awesome and I want all of you there. But for now, let's just talk about the route use project. So first, a little bit of background. Before we talk about what it is, it is, for one thing, a very old project. It was started in '95. And at this point in time, we have, I think the slide said 40 plus. We are over 50 now, collectors at internet exchanges throughout the world that is collecting BGP routing information from everybody that we peer with. We then store that data and make it available for researchers and operators free of charge to do with whatever they want to do. We're collaborating with CAIDA, and we are funded by NSF grants, that is the National Science Foundation in the US. And the project is based at University of Oregon. Okay. We are currently 6 people who are working regularly on the project. Not all of us are working full-time on it. Actually, I think it's only 1. But we all collaborate and we have different roles for operations, strategy, peering, and tool making. So 3 of us are here at APRICOT. You all know Philip and me, and then we have Truppel, the other Philip. So what is it that we can do with all that BGP routes that we are collecting? So basically, the idea was to set up a tool for network operators that you could look at the BGP table from all different locations of the world. Because if you're running your network, you know what's going on inside your network, but how to figure out what's going on outside of your network. In particular, these days, where not everybody is running a looking glass, we are providing a kind of a global looking glass with the collectors. So that means we are being used for reachability, hijacks, bugs, mass withdrawals, RPKI status, anything that has to do with BGP. We will help you work it out. So yeah, there are a lot of the free and commercial tools that people are using every day in their daily life that pulls in on the route use data. So that's AS-RANK as CAIDA. We are working in close collaboration with CAIDA. Hurricane Alexis BGP tool, Kentic Market Intelligence, monitoring, Catchpoint, and many, many more are pulling in our data, and all they have to do is, we're using route use data for this tool, and then you can do it. So are you building your own tool? You can also just pull down the data and use it. Here's an updated map, a map that needs to be updated about where some of our locations are. We are trying to make sure that we have a collector in every internet hub globally, but we're also very interested in the corners, the outer corners of the internet, so that our data can show what is going on there in order to provide the most comprehensive map of what is going on the internet today. And if anybody have any questions or remarks, throw up your hand or yell at me. I'll be happy to talk about it. So let's dive into a little bit of detail. What are we working on in the project these days? Again, the collectors that we run in in virtual machines, or the older ones are run on servers that we would ship out today. But today we mostly work in virtual machines. We're using the FRR routing daemon. And currently we've run through an upgrade, and we're now at version 10.5. Latest, we actually turned up a collector here on IIX Jakarta. So anybody here who's present at IIX Jakarta, we would love to be with you. Is there any IIX Jakarta people in the room right now? Anybody from the exchange? No? Okay. If anybody know them, please let me know, because I have a thing I need to talk to them about. Other recent additions is Puerto Rico in Latin America and Lagos in Nigeria. We have a list of new locations that we work through. We do not want to have 1,000 collectors all over the world, but again, we do have several internet hubs where we are not yet present, and we're still working on trying to get that, again, in order to get the best, most comprehensive picture of what's going on the internet. So traditionally, the consumers of the data that we have collected have accessed the data by downloading the files that are in the MRT format, downloading those using tools from CAIDA. But we are working on replacing that and updating that with an API instead. So in order to sort of work with the modern way of building software and building tools, we are providing the API. Not all of the collectors are in the API yet, but that will happen, we hope, within the next 3 months, 3 to 6 months. Today, you can also access the individual collectors using Telnet. Anybody remember the protocol Telnet? Yeah, some people still using? Actually, some people still do, because there are a number of operators who have scripts running that will log into our collectors using Telnet, do BGP commands to pull out data, and then log out again, and they will do that frequently. That causes some strain, operational strain on the machines. So one of the reasons for the API is that if you do that regularly and you want to pull data from the system, please use the API instead of logging in using Telnet. Another use case for a lot of people is to log in and run a few commands and then log out again if you're doing looking for a fault or just doing some research. And for that, we have created a looking glass instead. So please do not log in unless it's absolutely necessary. Use the tools that we provide instead to access the same data in a more kind way to our system, and also a more efficient way for you these days. If you work programmatically and you want to download a lot of data, we do provide an authenticated access using the excellent PeeringDB authentication module. So that's really good, and thank you to the PeeringDB folks for providing that. Here's the looking glass that I was talking about. Some examples of the looking glass. It's a completely traditional looking glass interface, though you will notice that you might be missing your ping and trace route capabilities and say, why are they not providing that? So usually when you look into a looking glass, that will be connected to a router. And from that router, you can see the immediate effects on the traffic from the routing table that is present on that router. Since our collectors are collectors and not routers, we do not have a forwarding table, which means that if you do any ping or trace routes from our collectors, it will use our transit interface, which means it's a completely different path than the routing table that you're looking at will show. So it has no meaning to do any pings or trace routes from the route use collectors, and this is why it is not available on the looking glass. Right. Yeah, this is normal interface for a looking glass. So, right. Another project we've been working on is BMP, and some of you will go, yay, you do BMP data, that's awesome. We can get all this information from everyone. Not quite. The BMP that we are collecting and making available is we are collecting it on the session that we have to the collectors to collect the data. So we do not have BMP sessions with our peers, but we have it between our backend and the collectors. However, it does provide us with all the updates that are sent to us from the peers, because that is the beauty of BMP. So the BMP feed is the feed that feeds into our live stream of BTP updates and messages that is also available through our backend. We used to use OpenBMP to collect that, but we had a lot of stability issues. So a project we've been working on for the past year has been to first off add some more hardware on the actual front end to the consumers. But we have also developed our own BMP collector software called Bimper, which is written by Anton. And that has provided us with not only the more stable environment to collect the BMP messages, but also a lot of monitoring and analytics from the actual streams. This means, and again, we have made sure that it's compatible with the format that was used by OpenBMP, so the consumers did just continue to have the same experience. Yeah, so put a note into, we were able to monitor the updates and messages better than we were before. That will be important later. Other stuff that we work on behind the scenes is general infrastructure updates, because we have a lot of data. It's very old. We want to make sure that we keep it. Also to make sure that Jim's project that he talked about Monday, can help us provide it for the long haul. We're changing the OS on the collectors, and we are trying to improve the performance of FRR. And we have spent a lot of time on slow and noisy peers. And one reason we have done that is not only did we see way more of them because we had the increased monitoring of what was going on with live updates and messages. So Bimper has helped us see more, and then finally also helped us resolve it. So this is a typical graph and a typical morning. I wake up, I log into I have coffee, and then I log into my machine, and then I go like, oh no, something is stalled. We have a lot of high in queues, and what's going on? So basically, what we saw was the top graph here is the in queue of BTP messages on one of our collectors. We'll see as one peer pops up to the maximum at 10K right away, and the other peers are slowly growing. We see the spike in messages. So the time is a little bit, that time and that time is the same. It's just bad graphing. This is the spike in messages that caused the in queue to be full. And this is a spike in messages being written to BMP that is also spiking. So we have the in queue is clogging up everything. And there were some weird queuing issues going on. And then the BMP messages dropped to 0 until at some point. Now here, I would go in and probably shut down the peer that was causing the trouble. And then messages will come up again here, but the BMP stream would have been stopped. So we would have to go restart that. That's been a daily cycle for a number of people on the team for a while, until we finally got a new version of the software and tweaked the little things ourselves. So now the clogged up queuing issues have stopped. But if any of you are peering with our collectors and have seen your sessions frequently be shut down and then reopened again a couple of hours later, most likely this has been the cause behind it. Anyways, what else are we working on? We are working on more collectors, and then we are working on a project that I'm very happy about. It's a peering portal. Because today, if you wanna interact with us, you can write us an email, you can fill out a web form, you can open a GitHub issue. None of those methods are very good, and none of them are sufficient for us either. So we're working on building a portal that will make any new peerings with route use way easier and give you a lot of insight into how your network is being seen by us. So stay tuned for that one. I am very excited about it. So yeah, I'm going to skip this because of time and come to the important stuff, which is how do you peer with route use? Well, we do have a selective peering policy. I know the next speaker is going to call us out on that, but I'm going to tell you why we have a selective peering policy. A peering policy is basically just a reason to say no. It gives you not an excuse, but an explanation why you might tell somebody, hey, a BGP session between our two ASNs is not a good idea. We have a lot of resources that we need to manage. That means that we would like to make sure that when we use resources on a bilateral session, it's a session that brings new value or extra value to the combined data set that we already have. Not all sessions do that, so that is why we want to make sure that we can say no to somebody, but most of them do. We are also peering with route servers, which means that we might already be seeing all your prefixes and your normal peering policy announcements. So adding a bilateral session will just means that we're doubling the data that we already have. There's no reason to do that. However, we would really love to set up a bilateral session with you if you want to give us your full BGP table. So why are we interested in the entire eBGP peering table from people? That is because a number of the consumers of our data are using that data to analyze who is connected to who, how, in the different local internet ecosystems. And I personally myself built a long career as a peering coordinator on exactly that information that you can get out of the table. So please share your full table with us, and we will be happy to peer, and it will make the combined picture of what the internet looks like better for everyone. And otherwise, we have all the usual combinations. We can peer in two ways, either at internet exchanges where our collector is connected, or by multi-hop sessions going to our collectors in Oregon. So again, this will be way easier for you to choose once we get the portal in place. But hit me up if you want to peer. We always talked about that. And the next great support it's very grateful for everybody who want to peer with us, but we're also very grateful for anybody who want to host a collector for us at an internet exchange that we're interested in being connected to. It can be IXPs themselves, it could be members on IXPs, and all we do ask though is that you help us with the transit, you help us with the IX ports, and with the virtual machine. All right. And here are the specifications. I don't want to spend time with that. The thing is blinking at me. It's like, Nina, stop, Nina, stop. So I will stop and just say thank you to everybody who is supporting us and ask if there's any questions. No questions? All right. I hope you didn't fall asleep. I tried to not speak in too monotone.
All right, thank you so much, Nina. And continuing on the track of BGP, we now have Thomas from the University of Strasbourg
Yes.
talking about a next generation BGP data collection platform. So please welcome to the stage, Thomas.
Okay, so good afternoon, everybody. So thank you for the introduction as well. Today, I'm going to talk about BGP monitoring, BMP, LPKI, LOV, ASPA, so quite a lot of exciting stuff. So let's get started. But this doesn't. Oh, okay, no worries. Amazing, thank you. Okay, okay, so probably most of you know BGP. It's the main inter-domain routing protocol used today. And with BGP, it's very important that we collect BGP routes from actual BGP routers so we can monitor and analyze BGP. And for instance, I guess we are all very happy when every year Geoff Houston comes on that stage and presents the latest statistics about BGP, and this is possible because we have this data. There are also many monitoring tools that are available, including some commercial BGP monitoring tools, and all these tools, they are possible because we have this data. So the routers that share their data, they are like satellites. Each of these routers, they only see a small fraction of what is happening on the internet routing ecosystem, because this is how BGP works. We only see the best path from a given router. And it's when we combine the data from all these routers that we can monitor internet routing at more globally. So this is like satellites. Each satellite sees only a small fraction of the Earth's surface, and when we combine the data from many, many satellites, then we can monitor the Earth's surface more globally. It's the same story. So historically, there are 3 platforms that collect BGP data, that store it and share it publicly. It's RIPRIS, route views, that we just learned about before, and PCH. And recent route views, for instance, today, they collect data from about 1,500 BGP routers that we also called vantage points. And this is, again, very useful data. So today, I am here to present you a new BGP data collection platform that is called bgproutes.io. It's a platform that we built at the University of Strasbourg in France. And it's a new platform because we launched it about a year ago. And perhaps now you wonder, why did we decide to build this new platform when there are already RIPRIS, route views, PCH, that collect a lot of data, and that seem to work rather well? Well, we decided to build this platform because typically when one wants to build such a platform and operate it, there are 2 main objectives. We want to have high coverage because we want to get as much data as possible. But in the meantime, we also would like to keep this data for as long as possible, because this is, for instance, useful for researchers. We love to go back in the past to make analysis and then to compare it with today, for instance. The problem, though, is that these 2 objectives, they are not easily compatible. In fact, high coverage means a lot of data, and keeping it forever means we need a lot of resources to do this. So usually what happens is that we need to prioritize things. And typically what happens with RIPRIS and route views is that they really want to keep the data forever. This is just what we saw before in the last presentation. And this is amazing because RIPRIS and route views, they keep the data for decades. So we can really go back decades ago, take the data, and do some analysis. The problem in the meantime is that if we want to keep all this data, it takes a lot of resources. So in terms of coverage, it's hard to get even more data. So today, and that's what we just saw before, RIPRIS and route views, now they don't have an open peering policy anymore. They have a selective peering policy, meaning not everyone anymore can peer with them, especially, in fact, if the data is redundant. With BGP routes.io, we do it the other way around. So we really want to put a high priority on coverage, even if that means perhaps eventually we will start discarding the data. Our goal with BGP routes.io is really to have highly accurate monitoring tools, real-time monitoring tools, and short-term historical monitoring tools. That's our main goal. So we also say BGP routes.io is a next generation BGP data collection platform because we don't just want to improve the collection of the data, but we want to improve the entire pipeline from better collecting the data, better storing the data, and better distributing it to the users. And this is what I'm going to present you today. So let's start with how we better collect the data. So to increase coverage, we rely on 3 key ingredients. The first key ingredient is that we have an automated peering establishment. So if you are in this room, if you're a network operator, and you would like to connect to BGP routes.io and start sharing data with the entire community, you just have to go on our website, bgproutes.io, and then you can authenticate using your PeeringDB account, so we know which AS you have. And then you just have to fill up a very simple form. It takes 2 minutes. Then you just have to configure the BGP session on your router. It takes 2 minutes as well. And you are connected with us, and you will start exporting the data to the platform, and users will be able to use this data. So after a year, thanks to this, we are now connected to about 70 networks. This is great. However, it's far from being sufficient if we want to have accurate monitoring tools. Okay, so we can look at this map, for instance, which is called a choropleth map. So basically, greener is the country, higher is the number of vantage points in this country. And you can see that we have quite a lot of vantage points in Europe and in the US as well, in North America. We have also one vantage point in New Zealand, for instance, but for many regions in the world, still, we do not have vantage points. So in these regions, perhaps the monitoring tools that we have, they are less accurate because we lack vantage points in these regions. So this is why now we rely on the key ingredient number 2, which is data aggregation. So with BGP routes.io, we not only rely on the data from our own vantage points, but we also take the data that is available in all the public BGP repositories, which are the repositories maintained by RIPRIS, RoadViews, PCH, and CGTF, which is a small platform in China. So we take all this data in real time when it's possible, and then we put it into our database. So if you go on our website, there are dashboards, and you can really see all these vantage points, and you will see from which platform they come from and which data they actually generate. So now, this is the map we saw before, but that is updated with all the vantage points now that we get from all these platforms. So you can see that now we are storing data for about 5,000 vantage points when everything works fine. And you can see now in this map that many countries are green now, more countries, but still, even if we take all this data, there are still countries in the world where there is just no vantage points. And that includes some countries in the Asia-Pacific region, by the way, so this is also why I'm here today, is to try to convince as many of you to peer with us. But to try to improve coverage even more, now we rely on the third key ingredient, which is BMP. So BMP can help here because the standard way to connect to a BGP data collection platform is with a BGP session. And BGP typically hides routes. So we will not see all the routes that we could actually see, and this is a pity. And this is what I'm going to explain you now with a very simple example. So imagine we have a BGP router, and that BGP router is connected to 3 networks, 3 autonomous systems. So it receives BGP route updates from these ASs. And when these route updates, they arrive into the router, first they might be filtered by the inbound filters. The route updates that are permitted, they then go through the decision process, then the RIB is calculated, and the best paths are then announced to the peers if they are not filtered by the outbound filters. So that's the typical BGP processing pipeline in a BGP router. Now, if we imagine that this router is connected to a collection platform like bgproutes.io, well, the good news is that we will see all the best paths that are not filtered, because this is what is announced over the BGP session. The problem, though, is that all the routes that are denied by the filters, as well as all the backup paths, are not announced over the BGP session. And that is really a pity, because the operator is willing to share these routes. It's just that these routes are not announced over the BGP session. And it's a bit sad, because perhaps in this set of routes, there are BGP hijacks, there are route leaks, but we will just not see them because, again, they are not announced to the platform. And this is typically where BMP can help. So BMP stands for the BGP Monitoring Protocol, and it's better than BGP when used for monitoring for two main reasons. First, because it can provide all route updates for every peer, and also because it can export the data for every stage in the BGP processing pipeline. And also, on top of that, it's very simple to configure. So let's take our previous example. You can see here that there are actually 5 stages in the BGP router. There is the first stage on the left. This is really where all the BGP updates, they just arrive into the router. It's before they are filtered, so it's all of them. There is another stage after the inbound filters. There is a third stage that is called local RIB. This is the best paths that are in the RIB. And then there are 2 more stages, one before and one after the outbound filters. So now if we imagine that the network operator configures a BMP session with the data collection platform, the operator can really decide for which stage the router should export the data to the platform. It can be one stage, it can be more stages. This is all configurable with BMP. And bgproutes.io supports one or more stages. This is all possible. But in the context of data collection here, what we recommend operators to do is to export the data for the AdIn pre stage. This is the stage on the left here. Why we recommend to do this? Because it's at this stage that we will basically see all the routes before they are maybe filtered. And also, if you do this, users will not be able to infer your routing policies, and this is probably something you would like. So if you imagine now that the operator is configure BMP and export data for this stage, what does it mean? It means that we will really receive the data, the BGP data, as if the data collection platform is directly connected to IS1, IS2, and IS3 with a BGP session. But instead of being connected to them with a BGP session, we just need this BMP session and we will get the exact same data. And this is really where BMP is sort of magic here, because it's one BMP session, but it gives sort of the data for 3 vantage points. So it's less efforts for operators, but it's more data for users, and this is really why we think BMP is the way to go for data collection. Okay, so as of today, bgproutes.io has about 15 BMP sessions with a total of 9 networks. And these 15 BMP sessions, they actually translate into more than 200 vantage points. And this is quite a lot of data. We have actually dashboards on our website, and you can look at them, and you can see these BMP sessions. And you can see also the number of vantage points that each of these BMP session they generate. And so, for instance, here, this is Nokia Lab that is connected to us with a BMP session, and that single BMP session gives data for 111 BGP sessions. So this is quite a lot of data just from one BMP session. Okay, so now I'm going to show you how we try to better distribute the data to the users. And this actually matters because collecting more data, it's useful, but it's not so useful when users, they are not equipped with the tools to better process and analyze this data. And typically, the standard way today to analyze BGP data is to process MRT files. So perhaps amongst you, there are operators or researchers that already wanted to analyze BGP data. And today, the standard way to do this is to download tons of MRT files, which are compressed, so you have to uncompress them. And where in these files, everything is mixed up. So you have information for different prefixes, for different vantage points. So processing all this data can be quite hard and can take a lot of time as well. So yes, with bgp-ras.io, we do store all the data we collect into an MRT archive, but it's not the way we actually recommend users to use if you want to analyze BGP data. So instead, what we are doing and what we recommend users to do is to use an API that we have designed. And we have designed it such that it's simple to use, it's fast, and it can also provide a very high granularity access to the data. So we have 4 endpoints. We have the vantage points endpoint, the updates, the RIB, and the topology endpoints. And each of these endpoints, they have a set of parameters. So you can build very flexible queries. And the goal is that you never have to download irrelevant data anymore. You can just get the slice of the data that you need. I'm going to show you an example here how this actually works. So imagine you are a network operator, and you want to retrieve all the BGP updates for which your ISN is in the IS path within a given time frame. And imagine, for instance, your IS3 here. Well, what you can do, you can use our Python library, which is called PyBGP-Routes API, and then you can use the vantage points function to get some vantage points. So for instance, here we want to get all the vantage points from bgp-ras.io and from RIPRIS. And then you just have to iterate over these vantage points, and you specify a time frame, and then you can use the ISPath regular expression parameter just to get the updates that match these regular expressions. So this regular expression, for instance, says that I only want to get updates with where they are IS3 in the ISPath. If you do so, this is what you will get. You will just get the BGP updates for which IS3 is in the ISPath. So this is perhaps just 4 updates, so you will just have to download and process 4 updates. So if you try to know a little bit about BGP, and if you are within the BGP community, you probably know that there are 2 very nice extensions to BGP that helps make it more secure. It's RPKI LOV and ASPA. And bgp-ras.io actually supports these 2 extensions. So quickly, I don't have the time to go really into the detail, but root origin validation basically enables verifying that the origin in the ISPath is legitimate. So for instance, this helps to prevent misorigin hijacks. And probably, or maybe, some of you are actually using it in practice. That's good. And the outcome here can be either valid, invalid, or unknown. For ASPA, the goal here is to verify that the ISPath does not violate the valley-free pattern that we can typically expect in an ISPath. So ASPA, it's a little bit more complicated because the algorithm is a little bit different if we receive the route from a customer or from a provider. So if it's an upstream ISPath, then we have to use one algorithm and the outcome can be either valid, invalid, or unknown. If it's a downstream ISPath, again, we have to use another algorithm and the outcome can be valid, invalid, unknown. So that's basically how it works in a nutshell. Now with bgp-ras.io, what we're actually doing is whenever we collect a BGP route, we directly mark it with its LOV and ASPA status at the time we receive that update. And then when you actually use the API and you retrieve BGP updates, alongside the time, the prefix, and the ISPAS, and some of the other attributes, you will also see the LOV status and the ASPA status. And this can be quite nice to analyze LOV or ASPA or do some measurement studies, for instance. The nice thing also with the API is that you can now filter routes based on their LOV and ASPA status. So, for instance, if we take our previous example, now in addition to the filters that I am already using here, I can also match on the updates which have a LOV status equal to valid or unknown, and an ASPA status equal to down invalid and down unknown, for instance. So what happens in this case? Well, only the first and the last update will be returned by the API because they match these criteria. But the two updates in the middle, they will not be returned because they do not match these criteria. And this is particularly useful, for instance, if you want to study the deployment of LOV or ASPA. And that is actually what we did last week. So last week, what we wanted to do is we wanted to analyze ASPA for downstream ISPAs. So we took all the updates that we collected within a 2-hour time frame, and what we found is that 99.3% of the ISPAs are unknown. But this is expected because ASPA is very new. There are only a few operators that have issued ASPA objects in the LPKI, so it's expected that most of the ISPAs, they are unknown. But what we have found as well is that 0.04% of the ISPAs are invalid. And this is quite interesting because these ISPAs, they are likely route leaks. It's just 0.04%, but actually this translates still into hundreds of ISPAs. So it's hundreds of potential route leaks here that we could find thanks to ASPA. And finally, 0.7% are valid. And these ISPAs, most of them are actually very short because shorter is an ISPAs, more likely it is to be ASPA valid. So now it could be interesting to redo that study maybe next month or next year, and hopefully we will see more ISPAs that are valid and less that are unknown, and also we cross our fingers to see less invalid ISPAs. Okay, so finally I want to conclude with some of the dashboards that we are also providing with bgp-ras.io, because we have found that some users, they really like the API, but most of the users, what they actually want is dashboard. So that's why with bgp-ras.io, we also built a few dashboards. We have a nice explorer, where we provide general information about ISCs, prefixes, IXPs, and all of this is calculated from the data we collect. We have also a prefix explorer, which is a sort of a giant looking glass. We have a vantage point explorer. So here we list all the vantage points. You can navigate through them and see the data that they generate. And finally, we have IceRank, which is a dashboard which ranks the ISCs based on various metrics. But the goal with these dashboards, it's not just to provide like some nice widgets or whatever. The goal is really like to connect users with the raw data, and this is not so simple because there is a lot of data there. Okay, so how we try to achieve this? Let's take a little example. This is, for instance, the ICE Explorer, and here I am taking an example with the APNIC Research and Development Network. So you can see in this dashboard, what we do, for instance, is we compute the ICE relationships. And then you can see, for a given IS, you can see the upstreams, the downstream, the peers. But typically, when we run a nice relationship algorithm, inference algorithm, we can do mistakes, right? Because it's a probabilistic algorithm. There is no grand truth here. And the thing is, what we are doing here is that we have this detail button. So if you click on this button, you really see the ISPAs that we use to make these inferences. So if there is a mistake, for instance, you can really see the data we used, and you can check it out, and you can see, oh, maybe there is a mistake because these paths, they are weird, or because there is a route leaks, or just because our algorithm did a mistake. That's also possible, but at least you can understand better why we did this inference. And we are doing the same thing, for instance, with our looking glass. So typically, a looking glass, there are a lot of entries, one entry for each vantage point, and each entry gives the route from that vantage point towards a given prefix. And here, you can see on the right side, we have a set of filters that you can apply. So you can navigate through the data very easily. So for instance, you can apply ISPath regular expression, community regular expression. You can go back in the past if you want at any point in time. And there are also some other filters if you're interested. So that concludes my presentation. So thank you very much. I hope you enjoyed it. If you're interested, you can connect to us, share data. We would love to have vantage point in the Asia-Pacific region. And to finish, also just want to thank our sponsors, the APNIC Foundation and OVH Cloud. Thank you very much.
Any questions for Thomas? Looks like you did a good
Thank
job.
you.
Thank you. All right, so now we are getting to our next presentation, which will be the APIX update. And please welcome to the stage Masataka Mawatari to give us an update on what is happening at the APIX. Please.
Yeah, good afternoon. I'm Masataka Mawatari. I'd like to share the APX update today. So this time, so we have APX general meeting 2 days ago. This time is the second time meeting in Jakarta. So the last time was in 2015, so it was 10 years, more than 10 years ago. And in terms of the number of APX members, we have 47 APX members IX, but this time Ryukyu IX withdrawn, so there is a -1 IXP. So this slide shows the APX members on map. So as I told you on previous slide, we have a total number 47 IXP from 20 countries and economies. So yes, of course, we have many IX members from here in Indonesia, AIX, BIX, CXC, Cloud Exchange, HNext, EPIX, APG IIX, and JKTIX. And this slide shows the APX steering committee for FY 2025. So the steering committee consists of 5 roles: chairperson, secretary, treasurer, outreach manager, and operations manager. And this time, Toyama-san and Arnold-san, they left from steering committee members due to the end of terms of office. And we had SC member election, and it is held during our APX member meeting 2 days ago. And for FY 2026, as I told you, so we had a SC member election. So these people current API steering committee. So me is a chairperson, and secretary is Isha, and treasurer is Robin, and Michael and Hannah. So they are newcomer for API steering committee. And we have a special team for preparing APIX meeting program. So we have 3 members for this project, Narel and Warren and Michael. So thank you for always for your contribution for preparing a great program. And I'd like to introduce the APIX meetings 33 here in Jakarta. And we had an APIX meeting 2 days ago on last Sunday. The number of attendees from 33 IXP, and the total number of attendees was 68. And this is the agenda for the last APIX meeting 2 days ago. Currently, this APIX meeting consists of 2 parts. The first part is admin session, and the second part is a tech session. So as I introduced you, we had admin session. And during the time slot, we had the AC member election, and we had a discussion about the legal entity. And the afternoon time session, so we had a great presentation from not only in APAC region, but also in outside of APAC region, so such as Brazil, IXBL, and DKX. Randy, thank you very much for your presentation for APIX. And we'd like to introduce our plan for 2026. Yes, we have a new APIX members, Michael and Nolan. So we are thinking of the improving our committee for APIX IXP providers. And we have usually 2 APIX meetings per year. And for 2020, so we have a plan to have 2 APIX meetings for 2026. And we would like to do new APIX members recruiting. And we are exploring the possibilities to collaborate with other organizations in APAC and global as well. And I'd like to introduce our great supporter. APNIC always supports our activity always. And the meeting room, Zoom link, and the things as well. So they are provided by courtesy of APNIC. Thank you for your support, as always, APNIC. Thank you very much. That's all from APIX update. Thank you very much.
Any questions from the room? Seems not. I think they're asleep. Thank you so much. All right. Now for our last presentation. We will be going into our Peering Personals Group 1. I'm looking for Archie. Has anyone seen Archie in the room? Okay, while we are looking for Archie, oh, there we have Archie. Woo, Archie! All right, while we wait for Archie to come forward, can we please ask the representatives from Abinawa Networks, AIX, BizNet, FiberNet, Herza, UpG, Jakarta IX, NTT, Sarta, you're here to help me, right?
I'm going to show the slide, so don't worry.
All right, cool. So if you are in group 1 for the peering personals, if we can please kindly ask you to come forward to stand next to the stage. Archie will then, of course, call you up to the stage, and that's it. All right. Now over to Archie. Thank you so much.
Thank you. Thank you so much. Okay, so before that, I also would like to acknowledge again the Peering Forum sponsors, BBIX and DKIX. As mentioned by Yolandi, this will be the sequence of the presentation. So if you are in the list, kindly form a line in this area. I'll give you 60 seconds. But anyway, as your slide is called, you can just jump in and move forward. Okay, so similar to last year, we have a special prize for the fastest delivery. We have our official timers. Where are our official timers? Hold on. I'm just checking the timer. So anyway, we'll have an official timer to check who has the fastest delivery in terms of peering personals. Again, for those attending or presenting the peering personals, earlier session in the first peering forum, we had choices of why you're here. So we will do letter D, a selfie of the speakers and probably the whole audience later. And then calling on the first one, Abhinawa Networks. Come up, please. A hand, please.
Hello everyone, we are from Abhinawa Networks. Our ISN is 1380077. We have traffic more than 4 terabyte, and we have been connecting with multiple IXP, more than 10 IXP in few data centers in Jakarta, also in Singapore. For more detail, you can visit as1380077.peeringdb.com, and if you want to connect with us, just drop your email on peering@abhinawa.co.id. Thank you.
Alien IX. So I'm just going to read through. You can check their peering DB record for inquiries and connectivity in their AX. BizNet. Okay. Just going to say what that's it. BizNet. Oh, not here. I'm just going to read through. AS number is 17451 and 3860. You can check their peering DB if you want to peer. FiberNet.
Hello, good afternoon. My name is Rengga. I am for Fiber Network Indonesia, also known as FiberNet. Our ASN is 58369. Traffic profile is eyeball. Our peering policy is open. You can connect to us in peering location like in the list and our peering DB. Contact me in the list. Thank you.
Thank you, man. Herza Cloud.
Hello everyone, I'm from APRICOT, IS number 140443, and traffic profile is content-able, so our traffic volume is around 100 gigabit per second, and our peering policy is open, and you can find us in peering location in the monitor, and you can contact me in rafi@herza.id for more detail. Thank you.
Thank you, Herza. Apchi. I'm gonna time you, man.
Hi, I'm Michael from AMG IIX. We have a lot of data center, and also we may be working also with data center to deploy our IX. Our current traffic is around 19 terabit currently. No, it's a peak traffic, and we also have in a many location in some other city. If you have interest to connect with us, please let me know, especially in some other city. And yeah, CDN are very welcome because CDN is not many in other city. Thank you.
Thanks, man. NTT Indonesia.
All right. Hello, everyone. Dito here from Cekere IX, part of NTT Indonesia. So we own our data center with 245 networks currently connected. We have two active data center now, which is JKT2 and JKT3. And then the upcoming one is JKT2 Annex, which will be ready around August this year. And then for the IX, NTT also own their IX in Indonesia called CKT IX. We have 780 IX number connected now. I think that's become number one still in Indonesia. And then we have 7 POPs around Jakarta, Surabaya, Bali, and Makassar. And you can check both the IXP and data center in our PeeringDB profile. Let me know if you want to connect with us. Thank you very much.
Thank you, man. Next is the Sarta.
Hello, good afternoon, everyone. We are from Lintas Arta. We are an end-to-end ICT solutions company. We provide both dedicated internet access and IP transit services under a single IS number, 4800. Our traffic volume have reached a peak of 2 Tbps plus. We are located in 38 plus locations in Jakarta and also Singapore. You can check the details on our PeeringDB. If you are interested in peering with us, you can send me an email or my colleagues. We are also open to hosting CDN nodes. Thank you.
Thank you. Matrix. I'm sure you can read, so appearing DB entry is there, and if you want to appear, just check it out. Next. Oma Data DC.
Hello, good morning, everyone. So I'm from Omadada DC. We're located at Surabaya, and we are opening up new locations at Makassar, Omadada Ediga UPG. So if you want to connect with us to discuss anything about data center or IX something, please let me know. Thank you. You can reach me out on there. Bye.
Oh, thank you. That was quite fast. Not fast enough. We have to wait for the rest. So you have to beat them. Next is Rapid Networks. Okay.
Hi, it's me again. I'm representing my ISP. It's a local ISP, and we have more than around 5 tera traffic. Thank you.
Oh, okay. -5 because you went up 2 times. Sorry. Oh, so the first round was more of the Indonesian network. So we now go to all other networks who submitted. First up is Akamai.
Hey, hi, this is Shovik from Akamai Technologies. Good afternoon, everyone. So we have three ASN 20940, 32787, and 63949, and those are for different purposes, which is mentioned. And traffic profile for 20940 is content, and mostly inbound for 32787, and variable for 63949. And traffic volume is 250 plus TBPS for 20940 and variable for others. Peering policy is open for 20940 and 63949 and selective for 32787. We have the following peering locations. Peering DB entry is given below and contact information as well. Thank you.
Thank you, Shavik. I'm 6.
Hello, good afternoon. My name is Wouter Ensing. I represent AMSIX. Beside Amsterdam, here in the region, we have peering facilities in Hong Kong, Singapore, Bangkok, and Manila. If you'd like to talk about peering, please reach out to us. Our details are here. Thank you.
Thank you. Oh, we have a challenger. BBIX. This might be a long one. Take your time.
Hi everyone, I'm Ariane from BBIX. BBIX has been busy growing its footprint across Asia, the US, and Europe. To give you an idea of our scale in Asia, we're anchored in Japan with over 25 data centers across Tokyo, Osaka, and Fukuoka. We have also built a really strong presence across Southeast Asia. We have 4 locations in Singapore, 10 in the Philippines, and 4 in Thailand. We also have 2 locations each in Hong Kong and our newest market, Vietnam, which is launching soon. On top of that, we're running 5 points of presence in the US and 3 in Europe. Altogether, this infrastructure supports over 950 ASNs and manages more than 13.6 tera at peak traffic. You can find all our specifics on Peering DB, and if you want to chat about how we can work together, just shoot an email to our global sales team. We're a tight-knit team, so we'll make sure that the right person from the right region gets back to you quickly. Thank you.
Thank you. BK Nix. Oh, let's see, Nan. 5 seconds.
Okay, good afternoon, everyone. So this is Nan, presenting BKNIC. BKNIC is stand for Bangkok Neutral Internet Exchange Point. We just don't have only exchange in Bangkok, but we also have regional exchange in Chiang Mai also. So you can find more of this entry in Peering DBs and Euro SP as well. So I'd like to highlight about our update. So we are one of the very first try to update the bird from version 2. Version 3 we have successful update on the Chiang Mai as well, and we just completely update to the Bangkok production as well on last 2 weeks. And we also certified as the social enterprise in Thailand. That means that we also keep the benefit to the community, not spread out to the any private sector. And we also have upcoming OCA appliance from Netflix, so that means the network in Thailand or peers can enjoy the CDN in BKNX also. We also open more CDN to the exchange, so please feel free to contact us. And last but not least, we have the peering forum, which is the peering event similar to this kind, but especially for Thailand and Southeast Asia. So please save the date on 25th to 26th May. And you can contact our team, me, Nan, and Bas. We will stay at the end of the event. Thank you.
Thanks, Nan. Digital Realty. Combo. Oh, triple combo. Quadruple combo. Oh, 60 seconds.
Oh, wow. Okay, selamat pagi. So we are the F4 of Digital Realty. So, woo! Since you are a US-based company, obviously, you know, our presence are globally everywhere. And since we are in APAC, so we have DC in Singapore, in Hong Kong, Korea, obviously India as well. Passing to Kobayashi-san.
Hi, this is Kobayashi. I'm in charge of Japan, and we will open new data center NRT14 in this April. And this week we got NVIDIA certified GB200 certification with NRT14.
Okay, hi, I'm Erlan from the Jakarta team. We do have two sites of data center, CGK10 and CGK11. So both of sites is connected with the APG. So it's the second house of the APG connectivity. So please reach us out if you need anything to connect with the APG in our data centers. Thank you.
Okay, last, and we just announced that we're entering Malaysia. So we just acquired CFS CX1 in Cyberjaya. So it's a very highly carrier neutral connected data center. We are going to upgrade the existing facilities, so we have room to new deployment or existing upgrade, and also we are planning to acquire lands around this data center, so for future development. So talk to us. Thank you.
Thank you. Eastern. Yes, you? Okay.
Good day, everyone. I'm Arvin from Eastern Telecom Philippines Incorporated, or ETPI. We are the one telco in the Philippines, leading telco in the Philippines, so offer IS, IX, and transport services. Our transport services offer nationwide coverage across the Philippines. Our details you may check in our in Peering DB. And if you want to connect with us or explore partnership, please contact us. Good day, everyone. Thank you.
Thanks, Arvin. EWS TSNI, double square. Beam.
Hello, everyone. So I'm Bimbo from EWS DSNI, Double Square Networks, AS number 142271. And pairing policy is open. Traffic volume right now is 600 gig. And pairing locations in Philippines, the major data centers, VM1, VM2, VSR, STT MK2, and STT Quezon City. And pairing details is down, and you can shoot us an email anytime. Thank you.
Thanks, man. Hold on. Too fast. Time out. Okay, hold on. Wait. I'm going to stay here now. So this is what happens when there's no peering personnel. So it's a very quiet room, right? Almost there. I'm imagining that we are having a party right now. So this is a live network, live event, so these things happen. And we didn't prepare for this one, so let's blame someone. The last speaker. Sorry. The next speaker, perhaps. So we don't know who's the next speaker yet, so probably we'll see in the next slide. So hold on. While we're doing that, let's thank the sponsors again, BBIX and DKIX. Yolandi, you want to say something? That's okay. Commercial break. So we still have 12 minutes to go. Can't really show if you don't have any slide. We can ask the photographer to take a photo of the speaker on the stage. What? Let's wait some more. So after this session, we will have another peering forum. That will be more of a panel, But at the end, we will have the second batch of peering personals. So there will be additional announcement as well as what will happen at the end of the day, as well as the next sessions that will be in the same ballroom tomorrow. Socials. There will be a peering meet me, greet me socials just outside. So it's more of based on the website nibbles and drinks. So if you if you want to have a heavy meal, you can probably head off after that, or you can eat more if you like. Okay, what's next? So I'm counting the number of chairs in the room now. So let's see who which is vacant. But okay, let's do that. So when I entered Indonesia, I couldn't get in the e-gates because it was asking me to remove my hat. So apparently I don't have a hat. So what I did was I tied my hair and it didn't open. So I had to tie the hair 3 different hairstyles before it actually opened. And after that, so I was looking for my bag, which is not in the, where it's supposed to be. It was already in the unattended luggage because it took me around like 45 minutes to 1 hour. Is that right, Matt? So they were waiting for me and about ready to leave. Okay, what else? Oh, Yolandi is going to help me say something, so thanks. Let's give a hand for Yolandi, please. Okay, we're going to do jokes now, so okay. First up.
Why did the network engineer break up with Wi-Fi? Too many dropped connections.
Yeah. I think we suck.
We suck.
Okay.
How many network engineers does it take to change a light bulb? None. It's a layer 1 problem.
Come on, guys. You can do better than that. This is recorded, so please. Next.
What's a network engineer's favorite hangout spot?
Hotspot?
No, hangout spot. The LAN party. Oh, come on, guys.
It's a tough crowd.
Let's do Did You Knows. Did you know?
I can't read it.
Hold on. Oh, this is very random. Okay, so we're going to do random Did You Knows while we wait for the presentation. Did you know, did you know about 86% of people tried to plug in USB devices upside down the first try? That's most of us in the room. The first ever text message was sent on 3 December 1992, which simply said Merry Christmas. The Firefox browser logo isn't a fox, it's actually a red panda.
Yolandi, I'm going to go somewhere now, so you can stay there. Quick update while you're finding your jokes, so we're still fixing it, so still have
Stay tuned.
7 minutes to go.
What else can we tell them?
I can announce the next APRICOT? No.
Yes.
I go to jail next time. Next. Matt, you were saying something? Oh, yeah.
This is very bad.
This is, yeah, it's good. It's technical. That's all. Petra, you raise your hand. So let's let the, oh no, let's probably just call on everybody. Let's see who is responding. Yep, hold on, almost there. Not yet. Okay, joke time. Oh, there.
We have it. Oh, thank
okay.
goodness.
Okay. I am Globe Telecom 4775. 2 seconds. I think I win the next prize. HGC?
I'm Leo from HGC Global Communications. We have Global AS 9304, and we also have multiple regional AS number. This time, we would like to invite peering with our regional AS in Thailand, which is 142435, and our regional AS in Philippines, 137996. We are in M6 Bangkok and M6 Manila. Besides peering, we are also a transport provider in Philippines. So if you are in other location, we may able to bring you in. So please send us an email for the peering. Thank you.
Thanks, man. Next is InfiniBand.
Good afternoon, guys. I'm Glai from Infinivan. Our AS number is 135607. So we have a partnership with BBIX Philippines, transport nationwide. So keep in touch if you have requirements in the Philippines. Thank you.
Thanks, Clyde. That was quite fast. JP Nap.
Hi everyone, good afternoon. This is Chloe from JPNAB. JPNAB is one of the biggest IXP in Japan, which operates 5 independent interconnection networks in Tokyo, Osaka, Fukuoka, Sendai, and Sapporo. After several years improvement, we have already connected to over 280 AS number. And it is worth noticing that JPNAB's peak traffic has already achieved 8 terabytes, and it is still growing rapidly. Our remote peering is supported by IPTP, PCCWG, Aurelian, Epsilon, Bix, Getafix, and etc. So welcome to become our partner. And if you are interested in JPNAB service, please feel free to contact us via email. Thank you so much.
Thank you. Amrut.
Hello everyone. We are Emroot. It's number 7500. So we had 4 more new locations in 2025 with Red Letter. And if you have your presence at listed here, please contact me and let's pair with us. Thank you.
Thank you. Meta.
Good afternoon. I'm Alex from Meta.
Nikki from Meta. Hope you guys are having good conference, many good meetings. So we Meta AS number 32934. We have many locations, so for the detail, you guys can check in the peering DB. If you are interested in peering with us, you can submit the request through the website that it's listed there. And the APEC Edge team, Matt, Alex, myself, attending the APRICOT. So feel free to reach out and ask questions. Thank you.
Thank you.
Just want to say something. It's like every network here mostly is relying on peering DB. So keep your peering DB up to date. And if you want to sponsor, feel free to contact Peering DB.
Thanks, man. Maharnika? Maharnika.
Good afternoon, everyone. I'm Andy from Arica IX. Our ASN number is 9420. Here's our information, and you can shoot us an email, and we'd love to peer you guys. Thank you.
Thanks, man. MMIX?
Hello, area. My name is Temika. I'm from Myanmar Internet Exchange. Currently, we have 2 internet exchange. Actually, we set up that internet exchange at another city. We didn't list down here. So our total traffic is, aggregate traffic is around about UNG. We are using 2 AS number for Yangon and Mandalay. Actually, we are using another AS number for that when we are implementing under the APNI Foundation grant. It will be finished very soon and successful. Thank you, everybody.
Thank you. Route views?
Hello, this is Route Use 6447. Give us your full routes, please. Thank you.
Oh, that's fun. That's a quick one. SGIX.
Hello, I'm Tian Huat. I'm from SGIX. We are present in Singapore, so our traffic is around 4.98 terabits. We are using route server. So if anyone is pairing with us, in Singapore, you can contact us via the peering UV. Some others we have going to have 400 gig spots available by Q2. Okay, thanks.
Thanks, man. Silent Vision.
Hi, this is Darren from Mega I. We operate and run our iAdvantage IX. Our peering connections locations include Mega I as well as the other locations in our Mega campus. If you have any peering needs within Mega I or on our platform, feel free to reach us. All new partners are welcome. Thank you.
Thank you. Tamo Cable.
Hello, everyone. My name is Norihito Yasutaka from Tama Cable Network. Tama Cable Network is a West Side, Tokyo West Side local cable TV station, and 22.5 giga and 10 giga FTTH service. And the subscriber is 20,000 users. And the update is Tokyo site is 100 giga port already, and tomorrow and connected to links forever connected, forever pairing. Thank you.
Thanks, man. And that's the end of the first speeding personals, and also the end of and the next session will be for the Speeding Forum 3, which will start at 6:30. While I announce this, can I ask the other speakers to come up on stage? We'll have a group photo. And that's it. For the rest, I'll see you later. Speakers, please stay. Let's do a group photo. Speeding personal speakers. Group photo for the speeding personal speakers. Oh, and yeah, of course, you.